Hey, how you guys doing today? So today we're going to do a longest substring without repeating characters. Personally, I think this algorithm is kind of interesting because there's a lot of things going on in there. A lot of information you need to trace, and a lot update variables. For example, the max size. You need to update that really often, and also the last duplicate index. Sometimes you need to update, sometimes you don't. I think it's pretty interesting and really hard to trace those information, but you definitely need to read through this algorithm to fully understand what's going on. So then you can grab a piece of paper and then tracing all the information. So then eventually you will got it right. So here is the Java version of this algorithm. You can take a look. Take a screenshot, pause the video, something. It's up to you. And basically, this algorithm is actually find like, for example, ABC, ABC, BB. You want to find the ABC without repeating characters. So whenever we find ABC, whenever hit A again or B again, C again, that means it's repeating characters. So we only want to return the length of the first non-repeating characters, ABC, which is the length is 3. And for this one here, it's kind of interesting. The non-repeating substring is actually WKE because the first W and this W here and also that W is also kind of like repeating to each other. So then there's no point to trace that to show the length of that. Yeah, it's kind of interesting. You can pause the video, think about it, and see what do you think about it. I mean, I can provide the solution I think of, but I'm sure they probably have even better solutions. You feel free to comment down below the video and share your knowledge with everybody. So let's get into the Swift coding part. So here I already created this algorithm along with the tracking information. So hopefully that can help you to understand how those variables and the chart table is being updated. I will try to explain as best as I can. I know it's a lot of things going on in this algorithm, so it might be a little bit hard to understand first. So let's start from the beginning, creating this function. So we created this find the longest substring. First we check see if this word is a empty string or not. If it's empty string, we just return a 0. It's no point to ever go through the algorithm again. So then we created this chart table so we can actually keep tracking what kind of characters we already encountered. So if there's a duplicate, then we will be noticed later on in the loop. So then we can create this max length, which will actually count. I mean, not actually counting. It's actually to holding on the max length we've been through, the longest substring length. And this last duplicate index, it will be the as the name already stated, last duplicate index. So we obviously want to start this with -1 because the first index of an array of characters is actually 0. Then we want to basically just follow the Java algorithm. I create a chart array. I convert this string of words into character arrays. So then I loop through this character arrays. Then first I want to find the current characters of this character array, which for example, we use the example here. Hopefully you guys can see all of them, include the loop algorithm. So currently we have this array, we have this character is A, as you can see right here, the current chart. Then we want to check if this current chart is inside the chart table. So at first the chart table is empty, so obviously we're not gonna hit this point inside this if-less statement. We're gonna skip that into let current length equal to I minus the last duplicate index. So currently the last duplicate index is actually -1. So the current index is 0. So 0 minus the -1 is actually equal to 0 plus 1. So the current length is actually 1. Then we compare the max length, currently is a 0. So which one is the greatest? So obviously 1 is greatest, so we assign the 1 to the max length. So max length currently is 1. So then we update the chart table. We assign the character as a key, the index as the value. So you just continue to follow that loop, and you can trace it through the ABC and ABCBB. You will eventually find it's quite interesting, and you will really get lost if you didn't pay attention enough to understand this algorithm or how the data being assigned to each variables. So let's trying to go through them. So the second character is B. Second character is B. So we input this we insert this B character inside the chart table, which currently we have this chart table right here, which we don't have the B, which we skip this if last statement. We go into this current length. So currently the index is 1 right here, minus a last duplicate index. Last duplicate index is still -1. We didn't change anything. So 1 minus a -1 is equal to 1 plus 1, which our current length is 2. So then we want to compare the 2 with the previous max length, which was 1. Which one is the greatest? Which is 2. So we assign 2 as the new max length. Then we update this chart table, and so on. So then eventually we're gonna hit like a B and a B. This is coming into a pretty interesting. So so basically, whenever you hit a B here, it actually, if you input into the chart table trying to find it, it's actually it will give you this B's index, which is 4. Not this one here. That's the one interesting about the dictionary inside Swift. For more information, you can definitely go read about like Swift dictionary stuff. It's really interesting. So then, so on, you will eventually find the max length is 3. So this is how you get the max length of longest. This is how you get the length of the longest substring without repeating characters. It's quite complicated, I would say. Hard to trace those information to understand what's going on completely. Might need to take some time and pause the video or start to think about how exactly it works. And you might have a better solution than this one here. I mean, for me, I just kind of converting from the Java algorithm into Swift. But hopefully this can help you a little bit more. I would definitely update my GitHub account on the Swift algorithm part with a complete version of this. There we go. Finally, here's the result is 3. And we also can uncomment this 2 here, so you can see what's going on. It might take a while to run this. There you go. So as you can see, the result of the first one, ABC, ABC, BB, is length 3, which is exactly from the example input from above. Same as the BB, BB is only 1, and PWW, KEW is returning 3, length of 3. I think down there, I can output 1 for you to see what's going on, but Here it is, guys. Here's the longest substring without repeating characters. It's quite an interesting algorithm, I would say. It's definitely challenging, especially you lost track of all the informations. But I would say definitely really helpful in some cases. But so on is actually, I would say, is a big O-N algorithm, like the O-N running complexity is a big O-N. So because like if you have like a string, the longest substring is at the very end of this string, or really long string, it could be running for a long time. Like right here, total 3 cases run like 19 times, which is pretty long, I would say. But it's kind of like a fun thing to practice on and to understand the logic behind it. Yeah, so enjoy it, and hopefully you have a good day, and I'll see you guys next time.